like Wi-Fi is an acronym for wireless fidelity. LIFI is an acronym for light fidelity. LIFI was developed by Dr. Harold Haas. Before we get into LIFI, let's review how Wi-Fi works. Wi-Fi uses high electro pulses of electromagnetic waves to send data from the internet to your personal device, whereas LIFI uses fluctuations in the intensity of light to transmit data to your phone or your computer. But why should we use LIFI over Wi-Fi? One reason is speed. LIFI has showed data transfer rate of approximately 200 gigabytes per second in lab environment, and about 1 gigabyte per second in the real-life simulations, which is quite fast. Let's consider the average Wi-Fi speed of 33 megabytes per second in the country with the fastest Wi-Fi, South Korea. This means LIFI would be 33 times faster than the fastest Wi-Fi. Moving on to ethical issues. The next aspect is security. When it comes to Wi-Fi, Wi-Fi signals can pass through walls and can be intercepted by a hacker. Compared to LIFI, it cannot pass through opaque material. This limits the coverage area to what a user requires, thus preventing a person with malicious intent to intercept the data communication. Moving on to the applications of LIFI. LIFI has a lot of applications, such as LEDs at the headlights of cars can communicate with each other. It can efficiently avoid accidents. The concept of the Internet of Things can be more achievable since the integration of more devices can be done with ease. Imagine every street light be Internet access point. The possibilities are increasing. We can say, where there's light, there's LIFI. Moving on to policies regarding LIFI. Here is a screenshot of the regulated power use for Wi-Fi access points and antennae independently, by the FCC. The FCC has a threshold power per frequency of Wi-Fi. This regulation can come into effect with regards to LIFI. How? For instance, Wi-Fi frequency of 2.4 GHz is used for greater coverage area. This can be correlated to LIFI. By increasing power transmission on your LIFI bulb, the coverage area could be greater. The same goes for Wi-Fi frequency of 5 GHz being used for smaller areas. Lesser power transmission for LIFI bulbs would turn out to be economical and energy efficient. Let's see how this works. An LED light can be flickered on and off at a very high frequency. The on signifies a 1 and the off signifies a 0. This flickering happens so fast which makes it hard for the human eye to detect. That's why for us the light remains on, all the time. Here is how the flickering of the LED works. Data is sent to the servers via an Ethernet connection. Data is then transferred into the lamp driver that contains a software code to convert data from the internet into binary light flickers. The lamp driver is connected to the LED. It flickers for a certain pattern for a certain piece of data. Then, your phone's photoreceptor picks up these flickers and amplifies them. And there you have it, as it's displayed on your screen. Now moving over to a real demonstration by the founder of LIFI, Dr. Harold Haas.
We'll say, okay, it is nice, it's a slide created in 10 minutes, but not only that. What we've done is, we have also developed a demonstrator, and I'm showing for the first time in public this visible light demonstrator. And what we have here is an ordinary desk lamp. We fitted in an LED light bulb worth $3, put in our signal processing technology. And then what we have here is a little hole, and the light goes through that hole. There's a receiver. The receiver will convert these little subtle changes in the amplitude that we create there into an electrical signal. And the signal is then converted back to a high-speed data stream. In the future, we hope that we can integrate this little hole into these smartphones. And not only integrate a photo detector here, but maybe use the camera inside. So what happens when I switch on that light? As you would expect, it's a light, a desk lamp. You could put your book beneath and could read. It's illuminating the space. But at the same time, you see this video coming up here. And this is a video, high-definition video, that is transmitted through that light beam. You're all critical. You say, ha ha ha, this is a smart academic doing a little bit of tricks here. But let me do this. Once again, still don't believe? It is this light that transmits this high-definition video, this bit stream. And if you look at the light, it is illuminating as you would expect. You don't notice with your human eye, you don't notice the subtle changes in the amplitude that we impress onto this light bulb. It's serving the purpose of illumination, but at the same time, we are able to transmit this data. And you see even light from the ceiling comes down here into the receiver. It can ignore that constant light because all the receiver is interested in these subtle changes.